Hey everyone, today I'm going to be diving into reinforcement learning with human feedback. So, this is not really a tutorial on how all this works. Honestly, right now I'm just trying to figure out how it all works. So, I'm going to be prompting GPT to teach me all about reinforcement learning with human feedback. And for anyone that doesn't know, reinforcement learning with human feedback, or RLHF, is one of like the key reasons why LLMs are so good. It's one of the key pieces in training an LLM model. So yeah, if you haven't heard of it before, get to learn it with me while I just dive into reinforcement learning with human feedback, and I'll ask GPT a bunch of questions about it. Right now, I've asked it, I simply prompted it, can you teach me RLHF, reinforcement learning with human feedback? And it said, reinforcement learning from human feedback is a technique used to train machine learning models, especially large language models, in a way that aligns their behavior with human preferences and values. It combines the principles of reinforcement learning with feedback provided by humans to create AI systems that are more aligned with what users want or expect. So what I'm thinking right now is it helps. This is what I was thinking before I started asking GPT, and I kind of want to confirm that my thinking is correct. But when you train a large language model, it's essentially just a next token predictor. So you create this language model that is able to predict the next words given like a group of words. So pretend it's given two words, I love, based on the language that it's learned and that it's modeled. It will predict like 70% of the 70% of the time it should say you next after that. So it builds all these different probabilities, like based on the input, what's the probability that this is going to be the next word. So that's kind of how the language model is built. And then when like generating these long sentences like GPT, it essentially just starts off with a word or a few words or like a bag of words, and then it starts like generating the next, like the rest of the sentence word by word by analyzing like the previous words. And then like somehow it generates like useful information. But I think LLMs will produce a lot of garbage if they're just predicting the next word. So that's why we need human feedback in the loop. So I think that RLHF essentially allows humans to analyze the outputs of these LLMs and then figure out and then like kind of give like a ranking for the outputs. And then these rankings are given back to the model during training, or are used to train the weights so that it produces like outputs that are more aligned with what humans expect. That's kind of what I learned before about it, but yeah, kind of want to confirm that here. So yeah, this is not a tutorial. I'm just showing you how I learn about our like reinforcement learning with human feedback by just using GPT. Don't even have to Google anything. So yeah, what is RLHF, reinforcement learning with human feedback? Number one, the goal of RLHF. The main aim is to improve the quality, helpfulness, and alignment of AI outputs based on human judgment. Traditional training often lack a feedback loop that considers how useful, accurate, or contextually appropriate a response might be. RLHF introduces a way to add human values and insights directly into the training process, making AI's behavior more interpretable and valuable. So yeah, it seems like the goal of the AI is to build or like train the AI to produce output that's actually more useful to humans, and just yeah. So what is the RLHF training process? RLHF generally involves 3 steps. Pre-training. Initially, a language model is pre-trained on a large data set using traditional supervised learning. This step helps the model learn general patterns, language structures, and a broad range of information. That's the first step of the RLHF training. Step 2, collecting human feedback. Humans provide feedback on a set of outputs generated by the pre-trained model. Typically, this involves ranking multiple responses for a given prompt or flagging unwanted behaviors. This is John. If you're watching this video, this is probably how they train GPTs, or like how they introduce safeties into GPT, like trying to teach the GPT not to say anything too crazy. So this feedback becomes a crucial data set for training the reward model, which measures the quality of responses according to human preferences. So it looks like we collect human feedback and then we train a separate model to like be able to judge, like, that kind of understands how humans would rank outputs. And in step 3, reinforcement learning. Using the reward model, the AI undergoes reinforcement learning. It tries to maximize its reward by generating outputs that align more closely with the feedback it has received. Techniques like proximal policy optimization are often used for this step to refine the model iteratively based on rewards. Okay, that's the RLHF training process. Why is RLHF important? Our reinforcement learning with human feedback helps solve several issues that arise with LLMs. Like, these so much acronyms that are tongue twisters. RLHF. Okay, so alignment with human values. RLHF aligns with human values. It aligns the model's responses with human values, reducing harmful, bias, or irrelevant outputs. Increased helpfulness. Since the model is trained to prioritize responses that people find useful, it can better serve as a productive tool for various tasks. Improved user trust. By embedding human judgment into the training process, RLHF makes AI outputs more predictable and reliable, improving user trust in the system. So, yeah, I was kind of just getting a sense what RLHF is for, and it talks about the applications. RLHF is used across various domains where human judgment is essential for evaluating the quality of outputs, such as customer service AI, content moderation, educational assistive AI. So I asked it this next question. I said, is the reinforcement learning portion actually changing the weights of the model? Because before that, I thought, okay, only when we train the language model are we training the weights of the model. So that's what I was thinking here. But it seems like we change the weights of the models in the 2 different steps. We do it when we're pre-training. So when we're actually just like training the model and we're trying to understand the language and we're trying to understand the general patterns of the language, we're updating the weights. But then after we collect human feedback and we train this separate reward model, we also, after we train a separate reward model based on the human feedback, then we undergo training again. So essentially how I think this works is, okay, we train the model to understand the language. So we're pretty much like the loss function is like how well it's predicting, it is at predicting the next word. So if every time it gets it wrong, that adds to the loss function. It tries to minimize the loss, so it optimizes the model based on that. And then after, we use that language model to just produce like random sentences based on like user questions. And then we have humans rank those specific outputs of the LLM based on like how helpful they are. And then from there, we create another model that understands how humans are ranking them, and we train the model to rank LLM outputs the way that humans would rank them, and that's called our reward model. And then finally, we take our language model and we make it produce a bunch of different outputs based on specific questions, and then we use that reward model to like judge the outputs of the LLM, and then like using like basically it tries to optimize that reward model output. So pretend it produces output and the reward model says 10. That's good. Like the higher the better, I think. And then it produces another output. It has 1. Or the reward says 1. So it's trying to it doesn't like 1, so it changes the weight so that it could like increase the reward function. So that's kind of what I got out of that. So Yeah, is the reinforcement learning portion actually changing the weights? So let me take a screenshot of here. I think that's step 3 here, and I'm just gonna like screenshot that to pin here. And, like I'm trying to explain over top of it because I need to like understand this myself as well. Reinforcement learning with human feedback. I love this topic. It's a fun buzzword to just randomly bring up. Sometimes I catch myself just saying this word. So pre-training. I kind of want to understand these different steps, but specifically, I kind of like know how this pre-training works because I built a language model before. But I don't know how the reinforcement learning works. I didn't know that that was even a thing until recently. So so I'm wondering step 3, is the reinforcement learning portion actually changing the weights of the model? And the answer is yes. The reinforcement learning portion in reinforcement learning from human feedback does actually change the weights of the model. During the reinforcement learning phase, a process like proximal policy optimization is typically applied to update the model's weights based on the reward signal that reflects human feedback. Here's a more detailed look at how this works. So we're diving into step 3 here. Reward model. First, a reward model is trained on human feedback data. This model learns to predict how outputs align best with human preferences, essentially scoring different responses for the same prompt. Yeah, so they're trying to train a reward model. Basically, they're trying to train a separate model that's able to like give a reward function to another LLM, and it gives a bigger reward if the LLM output is good, and gives a smaller reward if the LLM's output is bad. So that's what this reward model is doing, and that requires its own training process, and training that model involves human feedback. Cool. Policy update. Using reinforcement learning. Once the reward model is ready, so the first step is training the reward model. Once it's ready, it is used to guide the fine-tuning of the language model's policy. The language model generates responses to various prompts, and the reward model scores the responses based on how well they match human preferences. Through reinforcement learning, the weights of the language model are adjusted to maximize the expected reward, effectively steering it towards behavior that aligns better with human feedback. So I think this is basically what I was saying earlier. But yeah, that's actually interesting way to think about it. Like pre-training is actually just like figuring out the weights, and then the reinforcement with human feedback is more like fine-tuning the model so that it's more like aligned with what humans want. And I'm pretty sure this is also when they introduce all the safeties and all that stuff to make sure that it's not saying anything out of pocket. Like Cedric's my friend, and he kind of he didn't really like before. He pretty much only hit the pre-training part, so he would just say everything with no filter. But me and my friends have been like every time he says something out of pocket, we've been giving him a small reward for it by either not laughing or telling him that was messed up what he said. And that's the human feedback, and over time he has introduced more filters, and using reinforcement learning he has improved his weights to like say less out-of-pocket stuff. I think that's more of the human analogy there. So in essence, the reinforcement learning step, where was I? So in essence, the reinforcement learning, or where I was here at the iterative weight. The RL algorithm such as PPO optimizes the model's weights iteratively, using feedback from the reward model to reinforce good responses. Those that score well, and like we reinforce good responses and discourage bad ones. The model learns through these reward guided weight updates, adjusting itself to produce outputs that are more in line with human expectations. So in essence, the RL step in reinforcement learning with human feedback changes the weights in a way that moves the model towards generating higher reward responses, effectively reshaping the model's behavior to be more aligned with human feedback. The reinforcement learning process does modify the underlying parameters, refining the model beyond its initial supervised training. Okay, cool. So I get that reinforcement learning step. It's more like fine tuning, but it's more fine tuning based on like human feedback. And the human feedback is not done by like just people sitting there analyzing all the outputs and assigning like a grade to the LLM output. It's trained by it's done by creating like a model that will do that, and that's probably more scalable than just having a bunch of humans. Although like I do know like this RLHF process involves like a lot of human labeling. Shout out to Naked Strawberry Banana. That's my first sponsor. Um, so I kind of dove into three right away because that's the part I was curious about. But I wanted to take a step back to step one. What is pre-training? So I asked this. So the first step of training the model is supervised learning, where it's just learning how to predict the next word, and that's what I said earlier. And what it's essentially saying is like, yes, exactly. In the first step of training an AI language model, the model undergoes supervised learning, where it learns to predict the next word in a sentence based on a massive data set of text. This stage is often called language model pre-training, and it's a critical foundation for the model's understanding of language patterns, grammar, context, and general knowledge. So I think pre-training here pretty much does that. It helps the model understand language patterns, grammar, context, and just general knowledge by just being trained on like a large corpus of text. And I heard GPT was like trained on the whole internet. I don't know if that's real, but like, yeah, pretend you train the model on all of Reddit data, and all it understands like the different patterns in the language Reddit users use, the grammar that Reddit users use, the context, the general knowledge, and then just scale that up to like Twitter, Facebook, like everything. So we're still diving into pre-training, how it works. Objective. The model is trained with a simple objective. Given a sequence of words, it predicts the next word. For instance, if the input is the cat sat on the model tries to predict mat. This process is known as next token prediction. Cool. Dataset. The model is trained on a large and diverse dataset, such as books, articles, websites, and other text sources. This helps it learn a broad range of information, including grammar, idioms, cultural references, facts, and general knowledge. Learning patterns and structure. During supervised learning, the model learns statistical patterns in the data, such as common word sequences, syntactic structures, and associations between concepts. It doesn't understand language like a human, but it learns a probabilistic association that makes it very good at generating coherent text. That's kind of what I was saying at the beginning. It doesn't really understand the way a human is, but it's just like learning to predict the next words based on like the words that it's seen like before it, based on the context, and then it just keeps predicting the next word after that. So pretend I have I love, and it'll predict you, and it'll predict the dot, and it'll try to predict what comes after that, and it could be a lot of different things. What's the most common thing? But it'll just randomly. It's just like a probability distribution. It just picks one of those. So limitations. At this stage, the model is not yet aligned with human values or task-specific preferences. It may produce plausible sounding but unhelpful, biased, or irrelevant responses because it hasn't yet received targeted feedback on what makes a good or bad output. So it kind of learned the language, but it's just hallucinating to the extreme, I guess. That's how we can think about it when it comes to pre-training. It just learned the language, but maybe it's like a toddler, right? They'll just be saying random stuff that kind of doesn't make sense, but you'll need to do human feedback in order to get them to understand like what sentence actually makes sense and what doesn't. So the supervised pre-training step creates a general purpose language model. It serves as the base model, which can be refined through fine-tuning in RLHF to make it more helpful. Cool. So I think that makes sense. Like if you want to build an LLM, the first part is just this pre-training, take a big corpus of text and train the model on that big corpus of text, and basically train it how to predict the next word given like some of the other words behind it. And yeah, that's kind of like this first step of pre-training, but that just gives you the base model. And to actually make this thing useful, you'll need human feedback. And I just keep reiterating this stuff because that's how I learn. I just keep reading it and I keep just refining my thought of how it works, and I just keep saying it out loud. But I'm mostly just saying out loud because I'm making this video. Usually it'll just be in my head. Cool. Okay, does updating the weights happen here as well? Yes, weight updates during the supervised pre-training as well. In fact, this is where majority of the model weights are initially learned. Interesting. So pre-training, we learn more of the weights. Here's how weight updates work in supervised training. This is kind of like a basic machine, like your traditional ML algorithms or neural network based algorithms, backpropagation based algorithms, where you have a forward pass. The model takes an input sequence, which is a partial sentence, and generates a probability distribution over possible next words. Loss calculation. So after, like, you take the model and then you feed it a sentence and it generates an output, then you calculate a loss function, like how close was it to the actual probability distribution for the next word. Or yeah, the model's prediction is compared to the actual next word. A loss function, often cross entropy loss, quantifies the difference between the model's prediction and the actual word. So you pass a bunch of words through the model, it predicts a word, and you basically calculate if it got that word wrong. That's a loss function. And if it did get it wrong, you use backpropagation to update the weights so that next time you run those same words across, like you pass those same words into a model, it doesn't get it wrong. If it did get it wrong, you literally just keep backpropagating and updating the weights so that you get closer to getting it right. So yeah, that's like, basically that's the process there. Feed something to the model, look at the output and compare it. If it's wrong, update the weights so that it's closer to the right answer. If it's wrong, go back, update the weights, and you keep doing that. And you don't do that just for one set of inputs. You do that for like all your data set. And essentially you're trying to build a model that kind of optimizes for like all of the different inputs. To get like 100% accuracy, like given each input, it produces the proper output. And like I think the bigger like piece of text that you teach it or that you want it to like learn, the bigger the model has to be, because the model has to encode all of this information. Like it needs to be able to, yeah, like the more data that you're trying to like train it on, the bigger the model has to be in order to like capture all that information. You can't just use a small model on a big data set because it just doesn't have enough weights or parameters in order to like actually fit that output, like be able to map those inputs to that output. It's been a while since I took an AI course, so that's kind of my explanation for it. Each time the model processes a new batch of text data, it performs these weight updates to gradually learn patterns in the language. By the end of this supervised pre-training, the model has learned a rich representation of language based on the probabilities of word sequences and patterns in the data, setting up a foundation that can be refined with additional training like RLHF. So how does RLHF update the weights? And you can see I was kind of confused at this point. I'm like, how specifically does this thing work? So in reinforcement learning from human feedback, weight updates are performed using a specialized reinforcement learning process, often with an algorithm like proximal policy optimization, PPO. Honestly, I never heard of this algorithm before. I'm going to be studying that sometime next week. Here's a step-by-step breakdown of how RLHF updates the weights. Step 1, train the reward model. So now we're kind of here in step 2 of like the general training process for LLM. but you're training the reward model, you're collecting human feedback. Human evaluators review several outputs from the pre-trained model and rank or label these outputs according to quality, helpfulness, or alignment with human values. Then, like after you collect human feedback, you train a separate model known as the reward model. It's trained using the feedback data. The reward model learns to predict a reward score for outputs based on how closely they match human preferences. So this reward model kind of learns, is like you're basically teaching something to be an evaluator, and you're trying to teach a model how to be an evaluator based on like the human feedback you collected. So you train a model based on human feedback, and then it learns to give feedback based on like the human feedback you collected. So later when you're running, like when you're doing the reinforcement learning part, you can just like, instead of when you're calculating the loss function, you're using that model to calculate the loss function instead of using something like cross entropy. Reinforcement learning fine-tuning. After the reward model is ready, the main language model undergoes reinforcement learning to adjust its weights based on feedback. Here's how. Get some water. This is fun though. Reinforcement learning with human feedback. If you're ever like perplexed on what that buzzword is, now you know. I'm not sure if it's a buzzword. I don't hear it that much, but like it's pretty key in LLM training. Let me get a sip of water. Okay. Sorry. Reinforcement learning fine-tuning using PPO. After the reward model is ready, the main language model undergoes reinforcement learning to adjust its weights based on feedback. Here's how. Generate responses. The language model, which now acts as a policy model, generates responses to various prompts. Reward evaluation. The reward model evaluates these responses, assigning them reward scores. Higher scores means that the responses align well with human preferences, while lower score indicates poor alignment. So optimize with PPO. Loss calculation. The PPO algorithm calculates a reward adjusted loss function based on how the model's generated output aligns with the reward score. PPO adds terms to the loss function that both maximize the reward and limit drastic policy changes to keep the model stable. See, I want to dive too deep on that. Let's just go back into, this PPO thing. I need to study that more, and right now I'm just mostly focused on RLHF in general, and I'll dive into PPO maybe in a different video. But it seems like we do RLF fine tuning with PPO, and then step 3, repeat the process. This process is repeated across many batches of prompts and responses. The policy model, the main language, gradually adjusts its weights to maximize reward scores, leading it to generate responses that are more aligned with human preference. So summary of RLHF weight update process. Yeah, I think I went over that. So I was wondering, that reward model that is really important, RLHF, is it another neural network? So it went into it. It said, yes, the reward model in RLHF is typically another neural network. Its purpose is to quantify how well a model's output aligns with a human preference by assigning a reward score to each generated output. The score guides the reinforcement learning process, helping the main language model adjust its responses to better match human expectations. Structure of the reward. So now I was like diving deeper into the actual reward model, because there's two models involved here. There's the actual language model, the large language model, and then we have a reward model, which is kind of the evaluator that's helping fine-tune the LLM so that it can produce output that is more useful for humans. So the structure of the reward model. The reward model is often a neural network that can be based on the architecture of the main language model, but adapted for a different task. Scoring instead of generating text. In some implementations, the reward model is essentially a fine-tuned version of the language model itself, adjusted to evaluate responses rather than generate them. So it looks like we have another LLM evaluating another LLM. So we have our main LLM that we're training, which is like ChatGPT-3, and we have another LLM, let's call ChatGPT-3 Evaluator, whose job is to evaluate the outputs of ChatGPT-3 and basically assign loss functions to the output or loss values to the outputs of ChatGPT-3 and evaluate them and help ChatGPT-3 like guide them into building more useful response for humans. Whew, that was a handful. That was a mouthful. There's a lot of learning that's happening right now. So, training the reward model. The reward model is trained on human feedback data. Here's the process. Human feedback collection. Human evaluators review outputs from the pre-trained language model. For each prompt, they rank or rate the outputs, providing feedback on which responses are worse. Okay, so we have to take the LLM, produce a bunch of output. Then we have a bunch of humans actually like ranking which outputs are good. Dataset creation. This human feedback is used to create a dataset of ranked pairs of labeled examples that indicate the preferred responses. So now we have a dataset of LLM output and basically we have we label the dataset. The input is like a LLM output and the label is like a human's feedback to it. And we build a big data set of that. Then we train the reward model using this feedback data set. It learns to assign higher scores to outputs that are preferred by humans and lower scores to those that are less desirable. Function of the reward model. Once trained, the reward model serves as a proxy for human judgment. Okay. Cool. I think I said it right earlier. Because we don't want humans literally judging all of the outputs of the LLM. That's pretty inefficient and not scalable. So we actually want to train a model that will do that. And that's what this reward model is, and it becomes a proxy for a human judgment and not actually like a real human judgment. So evaluating outputs. When the main language model generates responses during the RL stage, the reward model assigns a reward score to each output, indicating how well it aligns with human preferences. Guiding reinforcement learning. These reward scores are used as reward signal in the RL process, typically with PPO. The main model updates its weights to maximize these scores, effectively learning to produce outputs that are more likely to achieve high rewards from the reward model. So PPO, it might be like back propagation or something. Not sure. Let's see. Let's see if I asked you any other thing. I think I explained it well. So is the reward model usually another LLM? Yes, the reward model is another LLM. Yeah, I just kept asking the same questions over and over with slight variation because I didn't understand, but I feel like now I understand it a bit. I think here I was more specifically trying to figure out more about this reward model. I was interested how this reward model is trained and what this reward model is, and seems like the reward model is just it's basically like a eval. What else? So it basically is like an eval, and I was wondering because LLMs produce like a stream of text, but what does this reward model do? Since they said that this reward model is also LLM based, but this reward model is a LLM, but it's a bit adjusted to not produce a stream of text, but to update or to output a number, a continuous number between whatever, negative infinity to infinity, and that number is used as a loss function. So I was like, yeah. So it says yes, the reward model or eval function typically outputs a continuous score rather than a discrete label. This continuous score represents a reward value that quantifies how well an output aligns with human preferences. Nice. How many different prompts in the model, is the model trained on for RLHF? So I was wondering, like, how many, like, humans have to, like, how many labels do humans have to produce in order to get a model like GPT-3 working? How many working for reinforcement learning? I don't even know. That's a question for a different day. So another thing that I was interested in is, like, what does RLHF for GPT focus on? Because if humans are labeling it, like, what are the prompts that it's labeling? Because it's giving human feedback on LLM outputs, but those LLM outputs are produced by some input. So, like, during the RLHF training, I think, like, the company who's creating the model, like, figures out what is going to be the most useful things for humans to label. So maybe it'll do a bunch of math questions and then get humans to label it. Then it'll do, like, some building essays and have humans write labels for it. So yeah, I think that's, I think I was asking what it was focused on, and it said RLHF process for GPT focused on improving several key aspects of models' behavior to make it more helpful, accurate, safe, and aligned with human values. So it focused on being helpful and relevant. So humans would just rank things based on how helpful and relevant the response was. It focused on politeness and tone. Definitely Elon Musk Grok AI was trained opposite of some of that. Accuracy and factuality, like actually making sure that the output makes sense and is actually accurate and not just like hallucinations. Safety and appropriateness. So this is like all of the avoiding toxic or inflammatory language. So introducing a bunch of safeties and biases. Carefully handling responses related to sensitive topics such as mental health, politics, and controversial social issues. So it's basically trying to make the model, making the model more politically correct, in my opinion. That's what they're training GPT-3 on. And yeah, that's kind of where I got with what I was learning. I'm not sure how long this video is, but that was my chat with GPT. Let's just recap everything that we learned. The RLHF training process, or reinforcement learning feedback, or reinforcement learning with human feedback, is a way that we train these big LLMs to produce more helpful responses for humans. And there's 3 steps to it. Step 1 is pre-training. So it's taking a language model and training it on a big data set using traditional supervised learning. This first step helps the model learn general patterns, language structures, and a broad range of information. So that's the pre-training, and that's where it's actually learning most of its weights. And then after that, after we have this model, this large language model that can produce, like, given input, given prompts, it can produce output. A lot of times it's probably gibberish or hallucinating and things like that. So we have the second step of collecting human feedback of the language model. So human feedback is when you take a set of outputs generated by the pre-trained model, and then typically this involves ranking multiple responses for a given prompt or flagging unwanted behaviors. This feedback becomes a crucial data set for training the reward model. So yeah, we collect human feedback. We take a bunch of LLM outputs and collect human feedback on those outputs. And then we train a model that's able to collect feedback for us, or able to rank the quality of LLM responses for us in an automated way. So when we when we go into step 3, which is reinforcement learning, we have this reward model. And using this reward model, the AI can undergo reinforcement learning, where it tries to maximize its reward by generating outputs that align more closely with the feedback it has received. Techniques like proximal policy optimization, PPO, are often used for this step to refine the model iteratively based on rewards. And yeah, that's kind of my conversation with ChatGPT about RLHF. I don't know much about it, and I'm going to continue learning more about it. And hopefully, in like a week or so, I'll give a deep explanation in RLHF. But that's, yeah, I just thought I had a good conversation with GPT, and I wanted to share me and GPT's personal conversation about RLHF, or reinforcement learning with human feedback, and show y'all how these models have gotten so good. Thanks for watching my video, and see you in the next one.